Section 3.1, we're going to talk about nth roots and rational exponents. The first thing you need to recognize is that whenever I say there's an nth root, that is just talking about what kind of root are we dealing with. We've already been discussing square roots, and you know that there's never a little 2 right here. They just as just the square root. Well, then sometimes we have the cube root, and how they do that is by putting the little 3 in there, and then of course there can be a 4th root, a 5th root, and so on. So for example, if I took the square root of 4, we know that the answer is plus or minus 2. If we take the 3rd root of 8, I have to figure out what number multiplied together 3 times will equal 8. And that is 2. 2 times 2 times 2. And in this case, it'll only be a positive 2. Because if you look at this, if we multiply negative times negative, that's a positive, times another negative, that would give us a negative under here. So that would not make sense if we put a plus minus. This would be just a plus 2. And there is also a key in your calculator that you'll need to know how to do this. And just for now, I want you to write down these steps on how to get a different root in your calculator other than the square root. And those buttons are math. So we're going to push math. And if you scroll down to number 4, you will see the cube root symbol. So when you push enter, something like this comes up. And for example, you could put 8 in there. And when you hit enter, you'll get the answer of 2. Now let's say you wanted a different root. Let's say we wanted a 4th root or a 5th root. What you're going to do first is on your blank screen of your calculator, you're going to punch in the root that you want. So let's say we were doing the 5th root of 32. So you would punch in a 5, and then you're going to hit math, and you're going to scroll down to number 5 where it looks like this, and then you'll push enter, and then you'll type in 32. And you want to make sure that your parentheses are correct. And I don't believe they even give you a set of parentheses for this one. So if you just push enter, you get an answer of 2. Alright, so that's kind of what we're going to be discussing. And in your book, they will tell you, find the indicated real nth root of A. So they're giving you what the root they want. So we're just going to fill that in. And they want you to find the 3rd root of negative 125. So if you go to your calculator and push math, go down to number 4, and hit negative 125, I get the answer as negative 5. Okay, now if you go to letter B, they want to take the 4th root. So the n is 4, and we're going to do it of 16. Okay, now we can't get anything higher than a 3rd root in our calculator without punching it in. So we're going to push 4, and then math, scroll down to number 5, and then punch in 16. And my answer that I get is 2. Now, there's one slightly difference here. We know that with cube roots, we cannot have a plus minus. But with a 4th root, we can. So here's just a basic rule. If your root here is an odd number, remember that you will never have a plus minus. It'll be either or. And if your root is an even number, which 4 is, you will always have plus minus on your answer because either one of them will work. Okay, rational exponents. There are two rules that you need to know in this section. I'm going to go ahead and write these down. Suppose you had a base with a fraction as an exponent. If the directions asked you to rewrite this as a radical, so we're going to rewrite this as a radical, it would look like this. The a goes under the root symbol, or the radical. The root, which is this bottom number of the fraction, will go in here. And then parentheses raised to the top number of the fraction. So, for example, let's say I had 5 to the 1/4, and I said, change this to a radical. 5 goes underneath. The bottom number is your root. And the top number is your parentheses, which in this case is a 1. It would just simplify to that, because really something raised to the 1 power is just itself. All right, and the next rule, exactly the same, except for we know that if we're changing this to a radical, when we have negative exponents, we have to flip them. So it's just going to be the same exact thing as we got up here. It's just going to be flipped. Okay, so we flip it. And if using the example up here, if we have 5 to the negative 1/4, again, 5 goes in the radical, the 4 is the root. Technically, we would write it that way first, and then we would flip it. So here are a few practice problems. We want to write 9 raised to the 3/2 as a radical. So 9 goes into the radical. The bottom number is a 2. Now that goes here. We're going to change that in a second. And then parentheses to the 3rd power. Now you need to think about this. Do we ever say square root with a little 2 there? No, never. So if you want to write it out at first and then just change it, I would do that instead. And that is radical form. And if we wanted to go further with this, we could say, what is the square root of 9? Well, it's 3. And then 3 to the 3rd power is 27. And even easier, if I didn't even ask you what this was as a radical, meaning I didn't even care for you to rewrite it, and I just said evaluate this, you could put in your calculator exactly what I have here, and the answer would be 27. So really, you don't have to do it the long way. Okay, so the next one, I'm just going to practice getting in radical form because the book does want you to do that. So 32, that goes underneath. The bottom number over here goes as the root. The top number goes as the exponent. And now because it's negative, we want to flip it. And now that 2 becomes positive. Now, if I said to write it as radical form, I would say just leave it like this. If we went further, typing in your calculator, what is the 5th root of 32? And when you start doing these, you're going to realize you're going to memorize them. The 5th root of 32 is actually 2. And now we square it, so this is 1/4. All right, now we're going to solve equations when we have roots other than square root. So the first thing I would do here would be to divide by 2. And now, whenever we got rid of a square root, when we got rid of a square, we took the square root. So if we need to get rid of something to the fourth power, we're going to take the fourth root. And that will cancel out, and you'll be left with x. And the only thing you have to remember is my root that I'm taking, even or odd, it's even, so my answer will have a plus minus on it. And the fourth root of 81, you may not know that, but if you go to punch in 4, math, scroll down to number 5, 81, the answer is 3. All right, now for an example like the next one, we have all of this in parentheses raised to the third. So we need to get rid of this third power right away. How do I do that? I take the third root. That cancels it out and I'm left with x minus 2. Now, my root that I'm taking is an odd number, so I don't have to worry about the plus minus. Now, if you were to type in your calculator the third root of 10, you're going to get a long decimal. So for now, if you wanted to just leave it like third root of 10 without having to write all that decimal out, I would say this would be okay. And the last thing you want to do is add 2 to both sides. So x equals, this decimal really is what it is, plus 2.